Welcome to our February community call of 2024, taking place on Leap Day. So pretty exciting. Happy Leap Day, everyone. I'm going to go over these couple slides really quickly. Basically, the community call is for you guys. It's a way to connect with our community, to be able to chat with you directly. Like I said, please use the chat. We're going to have our team in the chat to be able to answer any of the questions that you have. And you can also raise your hand at the questions and answers portion at the end and speak with us directly. Cool. Our O.26 release, which should release hopefully tomorrow, if not next week. User-defined functions is now G8 in this release. Our engineer, Johnny, has been working on this for a while now. It's a really great feature to be able to define your own functions separate from the standard Bicep functions. We have really good documentation supporting this if you want to try it out for yourself. You could see in the Bicep GitHub or Microsoft Learn pages. We now also have support for function imports in Bicep param files, which had previously been throwing errors for some users wanting to use function imports when building Bicep param files. So that is fixed now, and now you can use that. When importing a type from an ARM template, we realized we didn't account for scenarios where ARM allowed values constraint was present, but only allowed a single value, which caused fatal crashes when using these scenarios. So now Bicep can handle single member unions imported from JSON templates. We saw an issue submitted for this, so hopefully that will be fixed now. Let us know if it isn't. Another bug fix, we found that when you use a whole resource body type as a parameter, it crashes with a failure. So we're blocking using the whole resource body type as a type. With an error diagnostic instead of it fully crashing, while we work on figuring out how to use resource type parameters and resource derived types together. Last, we added support for recursive build and publish output to the MS build package. However, you'll have to opt into this new behavior by setting the Bicep output style MS build property to recursive from flat to avoid any breaking changes. So if you don't use MS build, you don't really have to worry about this, but this will fix an issue that a user was having of MS build not being able to place a compiled Bicep output correctly when Bicep isn't at root level. Hopefully that makes sense, and I explained this pretty well. If not, please put in chat and our engineers can explain a little further about what they did. Future releases, we have some bug fixes always in each release and some features that we're working on but won't be out next release. So kind of bigger features that we'll be working on to be released in the future. So not many big changes to this slide. Okay, Angel, are you here?
Yep. Hi, everyone. I just wanted to give a quick announcement. There will be a couple of sessions at the MVP Summit. I know there might be several MVPs here in this call, and just wanted to make a general announcement. These are limited sessions under NDA, so want to acknowledge that it's not something everyone can attend. We still love that the community call is kind of our main source of feedback and all things there. But for these particular sessions, I just wanted to give a heads up, given there may be some MVPs that would like to attend. And if you are interested, well, these are the dates. So make sure you secure a spot. Thanks.
Cool. Thanks, Angel. All right, our first topic, the V2 formatter. Shenglong was hoping to get some feedback from you guys. Shenglong, do you want to share your screen?
Yeah, I can share. Just give me 1 sec. To make sure I share the right window. So yeah, hi everyone. So for context, in the upcoming Bicep release, we're going to remove the experimental feature flag for the V2 formatter. And some of you might have already been using it for a while, but for those who might not be aware of the new formatter, he basically implemented a more advanced pre-printing algorithm, which takes into account the maximum line length or print width to manage line wrappings to make the code more readable. If you are a JavaScript or Python developer, you might have already heard about the formatters like prettier or black, and those formatters all implement the same pretty printing algorithm. Now the thing that I would like to gather everyone's input on is what do we think the default value for the width option should be? Currently, the default width value for Bicep for the new V2 formatter is set to 80, because this is the same value that aligns with Pretty's default setting. And actually, the Pretty team advises against exceeding this limit, because they think anything above 80 characters is less readable. And also, if you search for the 80 character per line boundary, you'll find that it's actually a widely adopted coding convention. The Linux kernel actually uses this coding convention. So, and one fun fact is that this 80 characters limit can date back to 1928, when the IBM punch card format is invented, because it has 80 columns. So this is basically the rationale why we use 80 characters. However, if you do more search, you'll find that a lot of people are actually complaining about this limit for Prettier. This is why they exposed this as an option. And also, Linus himself actually several years ago complained about this coding convention because he thought that we're not, coding in the 80s where everyone has a small monitor. Now our monitors are getting bigger and bigger. So people with restricted hardware shouldn't make it more inconvenient for people who have better resources. So yeah, Black, on the other hand, uses 88 characters for their own reasons. So yeah, it seems that different people all have different opinions on this. So I think it would be, before I go ahead and remove the experimental feature flag, it would be nice to hear everyone's thoughts. I'll just conduct a poll. And to help us make decision, I've created this repository. I'll just share the link in the chat. So you feel free to go ahead and clone the repo to your local machine, and within the repo there's a default width folder, and under each subfolder you'll find a main.bicep file, and each folder has its own width setting to different values. So now let me share my Visual Studio window so you can see the code. Where's my Visual Studio code? Okay, so here's a sample Bicep file with the width option value setting to 80. So as you can see at the top, there's an array, and this array is pretty long, so it cannot fit in one line. So the formatter will change it to a multi-line array, and then we got another array that contains a for loop, and then a variable with the value being a lambda call, and it contains some nested lambda calls. Yeah, more array with the element being objects, and the resource with a for loop. So yeah, this is what it looks like with line length 80. And here's the same source code, but with line length or width set to 90. Now because the first because the width is wider, the top array can now fit into one line. So this will get flattened. Same thing for the second array. Yeah, and the rest of the source code is the same. Now here's the same file with line length 100. Now the only difference between between 100 and 90 is that this STG data array now gets printed out as a single line array because everything can fit in the 100 characters limit. Finally, there's another sample file with line length with width set to 120. So now everything got flattened, including the final custom function. Now this do get wrapped into 2 lines for the other options. So yeah, I would recommend that everyone clone the repo and try the different formatting in your Visual Studio to get an idea of how it looks like on your machine. But yeah, let me now create. Before I create the poll, let me see if there are questions. What happens to the resource declaration with long nested resource provider type when it exists the defined line width? So basically, the answer is the formatter will try to wrap the lines if it can, and if it doesn't break the parser. In case where you have a nested resource, and if the nested resource declaration exceeds the width limit, it won't wrap it. Same thing goes for the parent resource declaration. Like here, I have a really long symbolic name, but it doesn't make sense to break this line because you will break the parser. So the width is not a hard limit. It's just used as a guide for the syntax nodes. So now let me go ahead and create the poll. And just give me some time to. Well, actually, I just type. I'm not familiar with the poll app. Let me just type in the options here, and feel free to thumb up the options. I didn't put 110 because I think that's just a weird number. But if you feel like there are other numbers that make sense, go ahead and thumb up. Okay, it seems like clearly 120 is the winner. But yeah, I guess in that case, I'll just change the default option to 120. Yeah, and for your reference, the current window size is 9020 by 1080. So yeah, that's the first thing that I want to ask. And now that we got a default width option, I do have a follow-up question. So let me just copy this array. So for the new formatter, there's one feature or heuristic that we implemented for objects. So this feature is copied from Prettier. So basically, when it comes to splitting an object, the formatter will use width. So if I have a really long single line object, it will be wrapped, and if I were to format the file, it would print the object as a multi-line object. However, sometimes people may find it less readable, even if an object can fit in one line. So to address that problem, we have added special handling for objects. So basically, if there's a new line between the open curly brace and the first key of the object, we will force the formatter to print the object as a multi-line object. So the same heuristic is not implemented for arrays today because Prettier didn't implement this. So now because we have changed the default, we've decided to change the default width to 120. This does have some drawback because now if I were to format the file, you'll find that the array becomes pretty lengthy. Notice that this vertical line indicates the 120 length limit. So this array can even be longer. And you might find it less readable. So now my question is, should we implement the same heuristic for arrays? Meaning if I were to put the first element on a different line, and if I run format, the format command, it will print the array as a multi-line format. And if yes, should we enable that by default or set it to false by default? And if you want the behavior, you can turn it on yourself. That's my question. Now, there's one downside that I would like to mention with this heuristic. Initially, I thought this was a feature that Prettier implemented, but it turns out it's not. It's actually a temporary fix they applied to fix a bug. But later they find that they cannot revert it because they cannot. There's no good way to fix the issue. So the downside with this optimization is that basically this rule is not reversible. What does reversible mean? It simply means that if the formatter decided to split an array or object into multiple lines, it cannot convert it back. Like for example, if I added some elements to the object and run the formatter, and it becomes a multi-line object, and then I regret about the changes, and then delete the additional properties. Now the object only contains one or two properties. And if I run the formatter again, it won't convert it back to a single line object, and we will end up with inconsistent formatting. So personally, I'm not really bothered by this non-reversible formatting rule. I actually find it pretty neat as a Vim user because I can very easily convert the object to single line from single line to multi-line and vice versa. So yeah, I guess that's my that's the background. So now I will do another poll. I'll type the three options. The first one is to splitting arrays based on the first new line. Enable by default. Okay, I'll give people 10 seconds to vote. Okay, it seems most people are into the first option. So yeah, I guess I can probably turn on this heuristic for arrays. Yeah, I think that's all I had for today. Thanks everyone for your input. Back to you, Stephanie.
Thanks, Shenglong. This is great. Looks like a lot of people are really excited about this as well. Okay, we could move on to our next topic. We will point to the Radius team. I think, Ryan, you will be the one presenting, is that correct?
That is right. Hey, thank you, Stephanie. Thank you, Shenglong. Hey, folks, I was here a couple months ago, and I think I presented at the Bicep community call maybe 6 months ago or a while back, and I'm kind of back again. I'm going to give a little bit of a short demo, talk about what Radius is, and talk about some of the updates and things that we've been working on in Radius. And I'll try to be relatively quick. You'll see how this relates to Bicep pretty quickly here. So I'm going to share my screen. And Stephanie, be good if you can let me know if you can see that and if that looks okay.
Yeah, looks great.
Great, thanks. So, hey everyone, my name's Ryan. I lead a project called Radius. I'm from another team that's kind of a peer team of some of the Bicep folks here at Microsoft. And the mission of our team is to create open source projects that impact the industry. So if you've heard of projects like Dapper or Kata that are kind of big in the Kubernetes space, we're the team at Microsoft that originally created those and then kind of contributed them to CNCF. Radius is a project that I started a couple years ago around the time that Bicep was getting started, with a vision of improving the ability for ops folks and application developers to work together to deliver applications. And that's what I'm here to talk about today. Radius has been submitted to CNCF. I think the way to think about the current state of Radius is we'd like for folks to try it out, to give us feedback, to let us know if it's useful or not useful for your scenarios, and if it's something you're interested in using or contributing to. Love for you to come talk to us. I'll have some links later about how you can get involved with the project if you're interested in learning more. And so that's my team and my mission. We're a little bit backwards from most Microsoft teams. Most teams at Microsoft are thinking about building products and services, and then they might have an open source component to those teams or to those projects. The way that we think about things is that we do open source first, and if we're successful in open source, then it might become a Microsoft product or service in the future. So one of the trends that we've been kind of observing is a lot of enterprises and a lot of companies today are multi-cloud and are managing infrastructure and applications across multiple clouds. And I know we're mostly talking about Bicep here because this is the Bicep community call, but I'm kind of curious if there are folks that are managing applications on other clouds. Usually what I found when I'm talking to companies is people in the platform team kind of have to deal with everything. So if you manage infrastructure, you manage platforms at a company, you're probably working across multiple clouds. If you're only focused on one, I would say you're probably pretty lucky. one of the things that's accelerated development in the industry lately has been the adoption of cloud native as a paradigm, and in particular Kubernetes as a standardized app layer across platforms. So you can get Kubernetes cluster anywhere to run your applications. It's mostly going to work the same way regardless of what cloud you're on. So that's pretty cool, and everything should be easy, right? Well, it turns out that applications are a lot more than Kubernetes. You got to worry about Docker, there's Helm charts, there's the application itself, there's the things that the application needs in Kubernetes, or maybe you're using different services like ACA or ACI. And then there's all the things that are outside of Kubernetes that you need to interact with. If this is on Azure, it might be storage accounts, event hubs, Cosmos DB. If this is on AWS, it might be Lambda or S3 or SQS or Dynamo. So there's a ton of things that we need to manage as part of applications and infrastructure that we deploy. And what this looks like in practice is you might have good tools like Bicep, and you have all these different systems to manage. If you're deploying applications to Kubernetes, you're deploying Azure resources on Azure. If you're on AWS, you might have some CloudFormation, and you kind of stack up all of these things and use scripts and other tools to organize, and ends up being a little bit of a mess. If you do finally get everything working, and when you get deployment and things set up the way that you want them to be set up, you might come out the other end of that and go to the Azure portal or the AWS console, and you've kind of just got like a bucket of stuff. Like, here's a list of all the things that I created to support this application. And we don't have good ways to express the relationships, maybe the way the developers thought about it, and which infrastructure is going to be used for what. So Radius is a project that kind of harnesses a bunch of existing open source technology to try and improve that situation. And we're talking about Radius as a cloud native application platform that works on any cloud. The intention is that if you're building containerized applications, no matter what kinds of resources you're using, and no matter where you're running them, we want that to work. We want Radius to be a tool that works for you wherever you're going. So some of the components of this and some of the things that we're trying to solve, I'd say we're doing our job really well if we're helping teams work together. We know that in a lot of organizations, there are infrastructure folks and there are app development folks, or maybe you might have combined teams where you take a DevOps kind of approach. We want to help people who are experts in different things work together. And there's a variety of ways that organizations try to do this today. Maybe they give their developers access to the cloud, can sometimes end up being a mess. Maybe they tightly control access to the cloud, can sometimes be difficult or slow. The way that we solve that in Radius is with this concept called recipes that we'll talk a little bit about later. It's a way for platform teams and operations experts to decide the recipes and the templates that will be used for provisioning. Secondly, when we deploy your application, Radius captures a data structure that we call the application graph. So by using Radius to define and deploy your application, we're creating a record for you. We're basically automatically cataloging all the software and infrastructure in a way that you can understand the relationships between those things and how they relate to each other. If you've ever had to solve the problem of like, okay, I'm getting an alert for this database, but I don't know who's using that database, those are some of the problems we're trying to help you solve. And then lastly, we want Radius to be consistent across the places where you're deploying. Right now, we have good support for Azure and AWS, maybe GCP in the future, other things as people need them. I think the key is not every application runs across multiple clouds. In fact, it's pretty rare that a single application will span multiple clouds. I think if you have that need, you know about it already. But what we find is that teams end up being multi-cloud, organizations end up being multi-cloud, infrastructure management teams being multi-cloud. So we want Radius to be a tool that you can use across different places. I realize that I'm a Microsoft guy talking about managing apps on AWS. And if that's surprising, like, yes, that's really what I'm doing. I'm saying we're going to help you manage your apps on AWS. So how this works is applications come in, they could use a variety of open source or cloud vendor specific technologies. Developers define the applications. Radius acts as a control plane and helps you manage that infrastructure and deploy those applications on any cloud or edge infrastructure. What this might look like in practice and how we think about sort of the world is developers get to describe their applications the way that they understand the architecture. So maybe I have a front-end website that's talking to a back-end website. In my front end, I need a Redis cache, and in my back end, maybe I'm using Dapper or SQL Server for state storage. And then when that application gets deployed to an environment, in this case, it's a local dev environment. So I've got Kubernetes running locally. I can use recipes to run Redis in my state store inside the local dev environment. Then when I move across different environments, I could swap those recipes and use different infrastructure. So for example, if I'm going to go to Azure, maybe it's AKS instead of a local Kubernetes. Maybe it's Azure Cache for Redis or Azure SQL that we're using as a state store. And the same for AWS. We can substitute in different technologies based on those recipes. Whatever way that you use those technologies, whatever way you want to provision that infrastructure, as long as it's compatible with the app, it's good enough for us. Radius is the thing that helps you keep your app definition separate from the way that the infrastructure is going to be configured. And that's an overall picture of how these things kind of fit together. So just talking specifically about recipes, I think this is probably one of the things that's most relevant to this group of folks, where I think we could benefit from your feedback and your interest in this. When you think about recipes, think about, well, if I support application teams or I define the way that infrastructure is configured at my company, think about the work that you do to define and kind of codify the templates and the best practices that you're going to use to provision those things. Recipes allow developers to have access to that on demand as part of the application deployment, but still run with the credentials that you have as an operator and still use the approved templates and things that are configured. Recipes, I think, are a way to say to developers, you can create the things that I say you can create, and they're going to be created in the way that I want you to create them, which makes your compliance and policy workload a lot easier. I'm going to skip over that one and jump right into a demo. So I'm going to bring up a code space here, and somebody, if you could tell me if this font size is okay. I think it's probably right.
I think it looks good.
Okay, looks good. Thank you. So I'm going to give a very quick demo. There's a lot of things that we're working on in Radius that I'm not going to have time to show today, so love for you to come chat with us. And Anton, you got a question? No? Okay, went away. Reshma from my team is here in chat, by the way, so if there are questions in the chat, Reshma will try to get to you as well. And I'll stick around for Q&A when this is over. I'm going to walk you through a process of taking an application, and we're going to deploy this to a local environment running here inside my code space and to an environment in Azure and an environment in AWS. Now, I realize this isn't something that everybody does, and may not be something that you need to do, but you kind of think about the point of this as like, well, you probably do move apps from staging to production, right? We probably do move apps all the time across environments that maybe are configured a little bit differently, using different templates. And so it's beneficial to think about the way that some of these concepts might be leveraged in your scenarios, even though you're probably not doing, one app running on multiple clouds. So I've got a Docker file up on the screen. The reason I start with the Docker file is to explain the point at which Radius, I think, becomes relevant to folks. So I've got a node-based to-do application that I've already written and published here. So I've already written a Docker file. I've already published this to a container registry. I think Radius becomes relevant around the time you want to manage some infrastructure, or around the time that you want to run an app with real dependencies, maybe in an environment that's a lot like your production environment. The way that I'd get started with Radius, I'm going to skip over this in the interest of time. I'd run this command rad init. Radius provides a CLI. If you run this command and you point it at a Kubernetes cluster, we'll set up everything that you need with this. We have an interactive setup process to try and make this easy. Part of that setup is Radius would ask me if I've got an application in the current directory. And I do in this case, so I would say yes. What we'll do when that happens is we'll spit out a Bicep file. And this is the file that we would give you by default. It's got one container definition in it, and it's going to run this image that we publish as part of the Radius project. Now, some things to point out here. I know you're all Bicep experts, so I won't go over this in incredible amount of detail. You can see that we're importing Radius here essentially as a library. So if you've been following some of the work that the team's been doing around extensibility and external providers, you can kind of think about Radius as a library that's going to get used with Bicep. And the way that that works is we're teaching Bicep about the ability to call into our APIs. So by putting this import in here, Radius will show up. Right now, we've kind of got this weird thing going on where we have a fork of Bicep We're working with the team to converge on that, and that should be wrapped up in a couple months. But I could put Radius in here, and then I get access to these types like applications core containers. And everything that's in this application namespace, you can think of as coming from Radius. These are abstractions that you use to describe the requirements of your application. In my case, I'm going to run a container. And if you look at what's here, I'll trigger completion real quick. No suggestions there. If we trigger completion here, you'll see a bunch of things that might look pretty familiar to you if you've used one of these systems before. So if you've worked with Docker Compose or Kubernetes or other container platforms, you've probably seen all this stuff before, and you probably feel right at home here. So I'm going to run this container. I'm going to listen on port 3000. If I wanted to do other things like set environment variables, I could do that here. But instead, I'm going to highlight another feature. So this is a to-do application that we built. It's using Redis. It's a node container. I'm going to go ahead and add a Redis cache. And rather than using an Azure resource type or something like that that might couple me to a specific piece of infrastructure, I can use a Radius recipe. So everything here that's in applications comes from Radius. I'm going to pick Redis cache, and the editor knows how to complete that. So I'll fill in the required properties. I have to give this a name. I'll call it DB. And the two things that I have to pass in here, I have to pass in the application and the environment. You'll notice that there's no validation errors or nothing else that I'm being warned about. This is actually all I have to say to get a Redis cache deployed as part of this application. What's going to happen when I execute this Bicep file is that Radius is going to find the recipe that's been selected for me for this Redis cache, and it's going to use that recipe to create Redis. When I run this locally, it's going to just run Redis in Kubernetes for me. But when I go to Azure, it's going to use a Microsoft hosted Redis cache. And when I go to AWS, it's going to use an AWS hosted MemoryDB, which is one of the ways to run Redis on AWS. Another thing that I'm going to do here is I'm going to say something about how these things are connected. So I'll add a connection here. Connections are named because you can have many. So in my case, I'm going to call that connection Redis. And I'm going to point this at the database that I described here. So I'm expressing that there's a connection from this container to the Redis cache. Now this does a couple things. The connection, if I declare to something like a Redis cache that's an open source self-hostable technology, that's going to inject settings like environment variables into the app so that I can understand the username, password, URL that I need to connect to this. Basically, all the information that is required for an app to code against this Redis cache is going to get given to me by Radius. If I want to do something else, let's say I defined my own settings for this, which Copilot is going to help me out on, like, okay, I want a Redis underscore port environment variable. Well, Bicep has got you. Like our object models expose this data, and so you can compose that into any settings that you want to match what your app is doing today. Some other things that this connections node does that I won't have time to show, this can do managed identity for you. We really kind of want this to be like the easy button. This thing needs to talk to that thing, and it's our job in Radius to make that happen to you. So if this were like an Azure storage account or an S3 bucket, you'd be able to have Radius manage identity and permissions for you so that you don't have to manually script all that out. As we all know from our experiences with Bicep, like it's a good tool for managing that, but there's a lot of moving pieces to it. Be kind of nice if we could do it declaratively. The last thing that this does, and I'll show an example of this later, is that this will catalog all of the infrastructure for me. So I will know, Radius will know, and Radius will hold on to the fact that this container talks to this Redis cache, and we'll actually understand what the recipe did after we deploy it. So I'm going to go ahead and run this. I'm not going to actually walk through what the app does just in the interest of time. But what this is doing is, just to kind of demystify what's happening, inside my code space, I've got a Kubernetes cluster. Inside that Kubernetes cluster, I've got so nothing that I'm running in this console right now is connecting anything to Azure. It's actually going to spin up that app just in the Kubernetes cluster inside the code space. We're actually able to execute Bicep inside the code space as well. So I'm going to skip over actually testing out the app, but I'll just prove to you that it worked from seeing some logs. Like we actually got a connection to a Redis cache. We can see some logs from starting up Redis here. And this worked because the recipe that came with Radius for this is just going to run Redis inside my cluster. I'm going to step forward a little bit and think about what will we do to go to the cloud and how does this all work when I go to the cloud. And I'll demonstrate that really quickly by showing you what my environment looks like in the cloud. So I'm going to do radm show -o JSON, and I'll do that for my Azure environment first, and then we'll do the same for AWS. So inside my environment, I've got a couple recipes registered here. You don't have to understand all of this. We're kind of looking at raw API output data, which I think we're all a little bit comfortable with. You can see that I've got a recipe here for Redis cache. It's a Bicep template, and it's coming from this container registry. We also have very good support for Terraform as well. It's something we've been putting a lot of work into. If you have an estate of both Bicep and Terraform and you're kind of using both, that's something we'd love to talk to you about because we think Radius could help you kind of use those things together, especially if you're trying to migrate from one direction to another. One of the kind of cool things about this is as a developer, when I use recipes, I don't have to know which recipe was used, and I don't have to know what technology that recipe was implemented in. Again, if we look at this, there's nothing operational that I had to pass in here. I'm getting the configuration that my ops expert said I'm supposed to get. And in my Azure environment, it's going to be this template living in this container registry. If we repeat the same for AWS, again, I'm just getting the configuration of the environment in AWS. It's taking a little bit longer because Azure is better, which I just have to throw in an easy dig. But we'll see if that finishes. I don't know why it's taking so long, but the rub is I'll skip over this part in case it's going to get stuck. Okay, there it goes. We've got a Bicep template here for Redis. We built support for some AWS resources with Bicep. It's something we've been working on as part of the Radius project. We're not sure if it's a great idea, and we think it's kind of a promising idea. So if you're a Bicep fan and you're doing AWS, we'd also love to chat with you about that because we'd love for feedback on what this experience is like of using Bicep with AWS. We also have the ability to use Terraform, which more folks are going to be doing on the AWS side. I'll show you really quickly that we can deploy these. I did this while we were waiting and while Shenlong was talking to us about formatters. What I want to show you here is these are the commands I ran. So I did a rad deploy. This one's pointed at my Azure environment. This one's pointed at my AWS environment. So we get an Azure on the left and AWS on the right. I'm going to prove that this worked by showing you what the output looks like, or what do I get to see once something is deployed. So I'm getting the application graph from Radius and basically asking you, tell me everything you know about this application. So in Azure, you can see that we got this application is called demo. I've got a container confusingly also called demo. I've got a connection from the demo container to the database. So that's the connection that I wrote in Bicep. This list of resources right here, you can think of this like the infrastructure behind the abstraction. So when we handed Radius that container definition, Radius spun up all of this stuff in Kubernetes to power that container. For the Redis cache, if you look at this one, you can see that we understood that connection. And in the case of Azure, we made a Microsoft cache.redis, which is Azure's hosted Redis service. On AWS, the picture is mostly the same, but you can see that we made an AWS MemoryDB because that's what the recipe is configured to do in my AWS environment. And so you can see that there's a lot of power going on here in recipes, and also the fact that Radius is cataloging this infrastructure for you and giving you a way to interact with it that reflects the architecture of the application. So it's a little bit like a software catalog, but it's also a little bit more automated. Now, we do have a visualization for this as well. I'm not going to have time to show it today. It's something we're working on. This is kind of a text mode version of this. But if you want to imagine a big chart, kind of like we have the Bicep visualization that helps you understand the deployment job, you can think about the Radius app graph as like a big data structure that helps you understand the communication and architecture of the app rather than the deployment order of things. I do just want to show a recipe real quick, and then I'm going to yield my time so we can get to Q&A. This is an example of a Terraform recipe. I know what audience I'm talking to here. Just bear with me for a sec. I took a open source module for Terraform for MemoryDB, and I wrapped it into a Radius recipe. So you kind of think through the three things that recipes do is like Step one, we're going to get some data from Radius. So in this case, Radius is going to give us information about the environment we're deploying to. Step two, we're going to create the things we want to create. In this case, I'm showing the pattern for writing wrapping an open source module and turning it into a Radius recipe. And then lastly, I'm going to return some data to Radius to help us configure the connection that the app is going to make to it. If we look at a similar kind of recipe, can see that I was working on an example here with somebody. Yeah, I don't have that. I'll show you the one for Kubernetes instead. Looks like I edited this file. Actually, I can just get it back this way. Sorry. Let's get that back. All right. So you can see step one, we get some data from Radius. Step two, create the things you need to create. Step three, we return some data back to Radius so that the app can connect to it. And that's the general pattern that recipes follow, no matter what kind of thing you're trying to do. Then when developers need SQL Server, they need a Redis cache, it's going to look up the recipes that are configured in the environment and execute those in the context of Radius using the configuration that was specified by the person who authored the template or the person who configured the environment. And so that's what I wanted to show as far as a demo. There's a lot more we're doing. There's a way to use Radius that's a little bit more Kubernetes centric as well. I thought talking about Bicep would be a little bit more interesting with this audience. Some of the things that we're working on that are on our roadmap right now, we're going to put a lot more love into recipes and try to make that better for a lot more scenarios. So far, feedback on it is mostly good, but there's some things we need to solve, like versioning. I think a lot of people probably have a question about versioning after seeing that presentation. That's something we're thinking about. Another thing that we'll be doing with this is we'll be supporting Radius for non-Kubernetes platforms. So I've been working on support for ECS, which is a container platform in AWS. And we'll also be supporting one of the serverless platforms for container compute in Azure. We'll provide updates when we have something to share. I've got a couple more slides, and I'm going to paste these links in the chat when I'm done because I realize you're not going to be able to click on them easily. So if you want to learn more, some great ways to learn more. We've got a documentation website. You can visit us on GitHub. Love to chat with you on Discord. Likewise, if you like this, you want to learn more, you want to show your support, go star our GitHub repo. You can join a Google group to get news about announcements. We'd love for you to try Radius and share feedback. We've got a very short tutorial that you can do in a code space. It takes about 15 to 20 minutes. Something that we're working on, and if you're really interested in this, you want to help us out, we want to build up a community library around these recipes. And you can kind of think about it like similar to the official Bicep recipe or Bicep template repo. We want to leverage that as much as possible. So don't think about this as inventing something new, but more about like, how can we start using those things from Radius and make them easier for everybody to have access to? So that's some of the things that we're working on. We'd love to chat with you if you have feedback for us or further questions. And I'll hand it back to you, Stephanie.
Thanks, Ryan. Does anyone have any questions? You can raise your hand and ask here. Good. I guess we can just move over to our Q&A. I think those are all the topics that we have for today. I know that someone had asked for an update on what if support in the management group subscription level. I'm not sure if they're here, but let me find that comment. Chris, I think that was you who asked.
So I did get a clarification on it with regards to some technical aspect of Bicep as to why it didn't work. But I was confused by the answer because my base question is the what if stuff is kind of critical that it works correctly as we start to do more and more pipeline deployments. And it seems really easy for the what if stuff to get broken. And I'm wondering, how do we make it so that we don't break what ifs? Because what ifs kind of are key to, validating our deployments before we run them.
Yeah, I can answer that. For everyone who didn't see the GitHub issues, basically asking in a Bicep template, like why does a deployment what if not work with like management and subscription level or scopes instead of like resource group. And the reason for that was that Bicep what if has a short circuiting issue, which many of you may have encountered, and this is pretty common feedback that we've gotten on what if. And this is currently something that our engineer Johnny is working on to address. It's going to be a long process. I know a lot of people have been asking for this what if fix for a very long time, and we've just started the work now. So I have no ETA on when that'll be available, but it is something that we have begun the work on because I know we've been saying we wanted to improve it, and it's been a long time coming.
Okay. Is it possible to get a list of what causes the short circuit and how we can avoid them? My specific example was clarified, and I'm looking at it, was that I had a subscription deployment that created a resource group and created a sub-resource. The sub-resource referenced the resource group location, and that caused the short circuit. I mean, is there anything that we can look at from that standpoint to get a list of what not to do?
Yeah.
I'm happy to answer that question, Sydney, if you want.
Okay, go ahead.
So yeah, I mean, as part of the work that Johnny is doing, the three kind of areas that we're looking at are A, cutting down on the number of cases where we are short-circuiting, B, surfacing places that we are short-circuiting. So rather than just kind of silently saying everything's okay, we're gonna inform you if something is short-circuited. And then the final piece that we're thinking about is how we bring that into Bicep itself, so into the editor through some sort of linter warnings. Because I think the other thing that is challenging is, understanding why a particular decision results in short-circuiting happening. So we're kind of thinking about those three different areas to improve. Okay.
Excellent. Yeah, it just seemed weird that this was causing, and I'm showing it off to a client saying, "Ooh, wait, what ifs are cool?" And it comes back with, "Hey, there are no changes." Like, darn it, that's not right. While you're speaking, I also had a question about functions, user-defined functions going GA. I think you actually did a PR for that one issue. Is that going to make it in the next release?
Yeah, I think Stephanie, I think you shared the release plans already, but that's going to be in the upcoming release, probably early March. So previously there was a experimental feature flag for user-defined functions. Now it's just going to be enabled by default.
Beautiful.
Great. Hopefully that answered your question, how you liked it. I do see there are some questions in chat. Alex, are there any that we want to bring up? I know that they're being answered, but for the sake of the recording.
Yeah, I can answer in the recording or for the recording. So Kelly had asked if there are any updates on the public registry getting populated more completely. So when we originally started the public registry, we were taking contributions from Microsoft full-time employees, and it was a relatively sparse number of modules. There's a dedicated team in the Microsoft technical field, so they're not part of the product group. I think several of them are here, that are publishing a whole library of what are called Azure verified modules for both Bicep and Terraform. And so that's where all the energy is going right now, is into these Azure verified modules, or AVM modules, which are also in the public registry. They have a slightly different path for those modules, but they're very easy to discover, and they have a great website with all the details there. So I just checked, there's actually 91 AVM modules, and there's many more that are planned, and they take requests for new modules. So if you have a new one, you can submit an issue, and it just needs to be essentially sponsored by Microsoft FTE, because they're going to be the owners of that module in case there's any issues with it going forward. Mate, or if there's anybody else here who wants to add more accurate details than what I said, feel free to jump on.
Hi, everyone. Thanks, Alex. I think you summarized it pretty well. So there is an ongoing work, as you said. We are migrating assets from Carmel, the predecessor, which only focused on resource modules. In AVM, we are also going to introduce pattern modules, so higher level, maybe somewhat more useful constructs that end customers can directly leverage. And as you mentioned, this is an ongoing work. So there have been other modules that were published already in the public registry, some of which is overlapping with the AVM modules, but AVM, brings in certain standards. And as part of this transitioning, we are going to retire some of these modules that are now basically replaced by their AVM counterpart. And for those that are not directly replaced, we are going to consider migrating or evolving them to AVM modules as well. So if you check today, you, let's say, use VS Code as you are coding in Bicep, and you use IntelliSense to look for what modules are available in the registry, you would find that there are certain modules. Let's say a storage account module has 2 instances, which is fairly confusing. There is an AVM and a non-AVM version. So we are going to address this very soon. The non-AVM version is going to disappear. And again, all the ones that don't exist today in AVM are going to be migrated at one point in time.
Thanks, Mate.
Is there anything else I may be missing? Another message in chat. Yeah, Alex, there was a question about community-driven Bicep extensibility for cases when no product groups in MS are willing to pick it up, like Databricks, Fabric, Snowflake.
Yes, that is another good question. I think this is something that hopefully we'll have more details to share in the future. I think when we originally started the extensibility project, or the system to enable new providers in Bicep, we were, and still are, really focused on first-party cases, so Microsoft Graph, Kubernetes, things of that nature. But I think we're much more open to it at this point than we were maybe 6 months ago. So one of the things that we're going to be taking a fresh look at is what would be required to enable third-party extensibility, or kind of user contributions to extensibility providers. But we don't have really enough details yet to share. So I'm happy to share that it's something that we're interested in and going to explore in a little bit more detail. And as we have some of those details ironed out, we'll share them here.
Cool. Are there any other questions? Feel free to raise your hand if you'd like. Okay, then I guess we can end it here. Thanks everyone for showing up for our February community call, and enjoy the rest of your week. Thanks everyone.
Thank you.